Welcome to the Department of Distance and Continuing Education, University of Delhi. Master of Business Administration, Semester 1, Core Course MBA FT 6103, Managerial Economics. Lesson 3, Theory of Production. 3.1, Learning Objectives. The objective of this lesson is to introduce students to the concept and working of production in both the short run and the long run. This lesson will equip students with the necessary theory and techniques and the ability to apply them to inform and enhance managerial decision making, along with the use of economic tools to explain the optimal allocation of resources within the firm, and also use the tools of economic theory to obtain optimal production. 3.2, Introduction. In previous lessons, we have looked at demand, supply, and how the interaction of demand and supply affects market price. According to the law of supply, firms are willing to produce and sell more when the price is higher, and hence the supply curve is upward sloping. This lesson will examine firm behavior and supply side decision making. We will understand firms and their profit maximizing goals. We will identify the most profitable level of production for a firm and how its costs vary with output. Firstly, we will have a look at short-run production, when a firm can vary only one factor of production, which is called the law of diminishing returns. The second part deals with the long run, when all the factors of production are variable. We will also discuss how firms make decisions to achieve maximum profits. Many firms are operating in an economy at different scales. Some are large-scale firms operating within the country, some are multinational organizations, and some are small-scale firms. Every firm uses a different proportion of factors of production according to the scale of an operation, like there might be several pizza outlets like Domino, Pizza Hut, etc. in your city, but there might be only one dry cleaner shop. Many firms in a particular area determine their pricing and efficiency. Figure 3.1 shows the production decision making. Managerial decision making involves 4 types of production decisions. These are whether to produce or to shut down, how much output to produce, what input combinations to use, what type of technology to use. 3.3, Production function. 3.3.1, Definition. Production and cost. Production is the total amount of goods and services produced in a given year, and the cost incurred to produce these goods and services is called cost of production. Production function. It is the relationship between inputs, that is, factors of production like land, labor, capital, and entrepreneur, to produce a certain level of output. So, Q is a function of land, labor, capital, and entrepreneurship. Figure 3.2 depicts the production function. Figure 3.2 explains the 4 factors of production, namely land, labor, capital, and entrepreneurship, and their relationship with output. Production function in the long run and short run. The long run is a period long enough for all inputs or factors of production to be variable as far as an individual firm is concerned. The output will be increased by changing both labor and capital. The short run is a period so brief that the amount of at least one input is fixed and others are variable. Say, if capital is a fixed input and labor is a variable. Hence, an increase in production during this period is possible only by increasing the variable input. The length of time necessary for all inputs to be variable may differ according to the nature of the industry and the structure of a firm. Figure 3.3 shows the production function. Figure 3.3 depicts the production function. The x-axis represents the inputs and y-axis represents the output. The curve shows the relationship between input and output given the state of technology. Q is the function of x1, x2 till xn, where Q stands for the output of good per unit of time, x1 for labor, x2 for land or natural resources, x3 for capital, x4 for a given technology, x5 for entrepreneurship. F refers to the functional relationship. Function with many inputs cannot be depicted on a diagram. Hence, economists use a two-input production function. If we take two inputs, labor and capital, the production function assumes the form Q is equals to function of labor and capital. Relevance to business. Homogeneous production function helps businesses in deciding the optimal use of inputs given the input prices. For example, if he has to double the output, he knows by how much proportion he needs to increase the input as the production function is linear homogeneous. 3.3.2 Concepts of production. Total product. It refers to the maximum amount of output that can be produced by combining one variable factor with a fixed factor of production. Average product. It refers to the ratio of the total product to the total units of variable factors employed in producing a certain level of output. So AP is equals to TP upon L. Marginal product. It refers to the change in total output while producing one additional unit of a variable factor. So marginal product is equals to change in total product upon change in variable factors. Table 3.1 shows the relationship between total product, average product and marginal product. Figure 3.4 depicts the total product. The total product curve represents the total amount of output that a firm can produce with a given amount of labor. As the number of labor changes, total output changes. The total product curve is a short-run curve, meaning that technology and all inputs except labor are held constant. This assumption is keeping the other factors constant. In figure 3.4, x-axis is the number of workers and the y-axis is the quantity. The S-shaped total product curve has an economic meaning. At the lower end, where the number of workers and quantity is low, the curve is convex. Convexity means that when the number of workers is added, production increases at an increasing rate. This happens as more workers are added at low production levels. They can specialize in tasks and can work more efficiently using the fixed inputs as specialization is possible. In the middle production range, the slope of the total product curve gets flattened and the shape of the curve becomes concave. Concavity means that production increases but at a decreasing rate. The economic interpretation of concavity is that as more workers are added, there is less and less specialization available and the workers are less and less efficient in using the fixed inputs. Finally, the total product curve hits a maximum point after which output decreases with each additional worker. After the maximum is reached, additional employees don't add any valuable and are not productive and unable to use the fixed input efficiently. This pattern can be observed in figure 3.4 and table 3.1. Figure 3.5 depicts the average product and marginal product. Average product. The average product is output per worker. It can be defined as the total product divided by the quantity of the variable input, that is, the number of workers employed. In table 3.1, different values of labor are given and they can be determined at different levels of input. Thus, the average product of labor is maximum at 5 units of labor. Figure 3.5 graphically illustrates the average product of labor. The average product of the labor shows the efficiency of the input factor. The first unit of labor produces 10 units of output, and the second unit of labor, when combined with the first unit and the fixed resources used, produce 24 units, and so on. Thus, the average product for 1 unit of labor is 10 and for 2 units of labor is 12. An important point to note in this context is that when 2 units of labor are employed, the average product of labor increases. This shows 2 units of labor are more efficient than 1 unit. This does not necessarily mean that the second unit of labor is more efficient than the first unit. The increase in average labor productivity when the second unit of labor is employed in the production process is a result of more efficient use of both the fixed factor of production and the first unit of labor. The reason could be an increase in productivity and the production process becoming more specialized. This can also help managers in measuring the productivity of each labor, and they can accordingly reward labor because of higher per capita productivity. Marginal product. The marginal product may be defined as the rate of change in total output associated with the employment of one additional unit of the variable factor. The marginal product of labor can be computed as marginal product of labor is the change in quantity upon change in labor. The marginal product of labor is measured by the slope of the total product curve at a particular point, that is change in quantity upon change in labor. The slope of the total product curve is initially positive, meaning positive marginal product of labor, then 0, where the total product is constant, and finally negative marginal product of labor. Alternatively, marginal product per unit of labor input can be calculated over an input range by simply relating the absolute change in output to the absolute change in the variable factor. Thus, when the second unit of labor is employed, marginal product of labor per unit is average marginal product of labor is equals to change in quantity upon change in labor, that is 14. Thus, over the range from 1 to 2 units of labor, the average marginal product is 14 units. This distinction between the marginal value at a single point on a curve and the marginal value between the 2 points on a curve can play important role in making managerial decisions related to cost and output. 3.3.3 Relationship between marginal product and average product. 1. When marginal product is more than average product rises till the point the marginal product curve lies above the average product curve. The average product curve will rise. The implication is that the average efficiency of the variable factor is increasing. Second, when marginal product is less than average product falls. Third, when marginal product must be equal to average product, they both are at their maximum. Fourth, the point at which average product reaches its maximum is the point of maximum production that can be achieved in the short run, but this may not necessarily be the point at which profits will be maximized for that cost need to be considered as well. 3.4 Production in the short run. 3.4.1 Law of variable proportion. Holding all factors constant except one, the law of diminishing returns says that as additional units of a variable input are combined with a fixed input, at some point the additional output, that is marginal product, starts to diminish. Assumption 1. A production function is associated with a specific period. Second, the level of technology is constant. Third, the factors of production are divisible. Fourth, there are only two factors of production, namely labor and capital. Fifth, the supply of factors is inelastic in the short run. The three stages of the law of variable proportions are as follows. First stage, increasing marginal returns, is the range of production for which increases in variable input lead to an increase in the average product. Second, diminishing marginal returns, is the range of production for which increases in variable input leads to a decrease in the average product while the marginal product remains non-negative. Third, negative marginal returns, is the range for which the use of variable input corresponds to negative values for its marginal product. Figure 3.6 depicts the law of variable proportions. In figure 3.6, the x-axis represents labor, that is units of variable factor, and y-axis represents output. TP is the total product curve. Up to point A, the total product is increasing at an increasing rate. Between points A and B, it is increasing at a decreasing rate. Here, marginal product has started falling. At point B, the total product is maximum while the marginal product is 0. Thereafter, it begins to diminish correspondingly to a negative marginal product. In the lower part of the figure, MP is the marginal product curve. Up to point D, marginal product increases, and after that, the marginal product begins to decrease, and then the marginal product becomes 0 and turns negative. AP curve represents the average product. Before point E, the average product is less than the marginal product. At point E, average product is maximum, and then the average product increases, but after that it starts to diminish. First stage. The first stage starts from point O and ends up to point A. At point E, average product is maximum and is equal to the marginal product. In this stage, the total product increases initially at an increasing rate up to point A. Between A and B, it increases at a diminishing rate. Similarly, marginal product also increases initially and reaches its maximum point at D. In this stage, marginal product exceeds average product. Second stage. It begins from point A. In this stage, the total product increases at a diminishing rate and is at its maximum, and marginal product diminishes rapidly and becomes 0. The average product is maximum at point E, and thereafter it begins to decrease. In this stage, the marginal product is less than the average product. Third stage. This stage begins beyond point B. Here total product starts diminishing. The average product keeps on declining and the marginal product becomes negative. In this stage, ideally, firms will try to stop production. This happens because the marginal product of the labor becomes negative, implying that additional labor will give negative returns. Causes of increasing and diminishing return. Initially, due to the underutilization of resources and high efficiency, an increase in variable factors adds more to output. As we keep on increasing variable factors and as factors of production are imperfect substitutes for each other, so they cannot be replaced with other factors of production. The law of variable proportion can be applied universally in both primary and secondary sectors. Relevance for business. Businesses can increase productivity by employing skilled labor or more capital. If a nation invests in modern technology and better infrastructure that can improve the productivity of all the businesses and the nation as a whole, for example, China has invested its capital and this has resulted in growth in the average quantity of output per worker. 3.4.2 Economies of scale of production. When a firm increases the scale of production, they achieve economies of scale till a point, and then economies start to convert into diseconomies of scale. Economies of scale are of two types. Internal economies of scale. These economies are internal to the growth of a firm, such as technical, managerial, financial, etc. External economies of scales are external to the firm, and they happen as a result of changes in the external environment, such as localization, vertical disintegration, etc. Diseconomies of scale. When the firm overutilizes the used machinery, labor, increased plant size, etc., leading to an increase in cost of production, and hence the efficiency declines. This happens due to lack of coordination, depreciation of machinery, etc. When the factors are external to a firm, such as an increase in prices of inputs, taxes, lack of funds, etc., then they are called external diseconomies of scale. External economies and diseconomies. Relevance to industry. The concept of external economies and diseconomies have been used to classify industries into three types for determining the equilibrium. It can be shown by decreasing cost industry, where cost decreases as the industry expands. The constant cost industry has no change in average cost, and the increasing cost industry where the cost rise due to demand for highly skilled labor or better technology. Case study number 1. Apple increasing or diminishing returns. In some industries, securing the adoption and new technology is favorable to one's own product. As the product market share grows, the companies start putting more effort and money into marketing. Apple is an excellent example. The more customers start using Apple products and more applications are developed for iOS, the greater the demand for the product. As Apple introduces new products and upgrades every year, the increasing returns persist, and hence they are able to spend a proportionate amount of money on marketing efforts, and that is the reason that they are dominating the market. According to experts, Apple has introduced so many models of all of its products like the iPhone, iPad, and MacBook. Each model represents a considerable advance over the previous one, and the demand goes up as people are willing to pay for upgrades. However, there is limited scope for users to take advantage of these upgrades. Most of the products have similar features, and customers are unlikely to fully utilize the features with each upgrade. In this respect, Apple is a victim of the law of diminishing returns. The majority of the users may not be too impressed with the further capabilities of Apple products. Given the enormous cost of developing upgrades of the products, the question is, where does Apple go from here? At the moment, such products require a considerable investment from the customers, and also the company should be able to get increasing returns. 3.5 Production in the long run. 3.5.1 Returns to scale. The returns to scale is a long run concept. It shows the possibilities of different input combinations. In the long run, all factors of production are variable. No factor is fixed. Accordingly, the scale of production can be changed by changing the quantity of all factors of production. Increasing returns to scale. A production function for which any given proportional change in all inputs leads to a more than proportional change in output. Increasing returns to scale refers to a situation where all factors of production increase, but output increases at an increasing rate. It means if all inputs are doubled, the increase in output will be more than double. Hence, it is called increasing returns to scale. This increase is due to many reasons, like the division of external economies of scale. Figure 3.7 depicts the increasing returns to scale. In figure 3.7, the x-axis represents an increase in labor and y-axis represents capital. The combination of both the factors will produce more output, as can be seen in the diagram from point 100 to 200 to 600 units. Constant returns to scale. A production function for which a proportional change in all inputs causes output to change by the same proportion. Constant returns to scale refer to the production situation in which output increases exactly in the same proportion as the ratio of inputs is increased, meaning if inputs are doubled, output will also be doubled. In constant return to scale, internal and external economies are exactly equal to internal and external diseconomies. This situation arises when, after reaching a certain level of production, economies of scale are balanced by diseconomies of scale. Figure 3.8 depicts constant return to scale. In figure 3.8, x-axis represents labor and y-axis represents capital. Diagrams suggest that an increase in factors of production, that is labor and capital, are equal to the ratio of increase in output. Hence, we get constant returns to scale. Decreasing returns to scale. A production function for which a proportional change in all inputs causes a less than proportional change in output. It means that if inputs are doubled, the output will be less than doubled. If inputs are increased by 20%, the increase in output is 10%. The main cause of the decreasing returns to scale is that internal and external economies are less than internal and external diseconomies. Figure 3.9 depicts decreasing returns to scale. In this diagram, x-axis represents labor and y-axis represents capital. When inputs increase from 1 to 3 units, the increase in output is proportionately lesser from 100 to 150 to 180 units. 3.5.2 Isoquants. All inputs are now considered to be variable, both labor and capital in our case. How to determine the optimal combination of inputs? An isoquant is a curve showing all possible combinations of inputs physically capable of producing a given fixed level of output. Figure 3.10 depicts isoquant curve. In figure 3.10, x-axis represents labor and the y-axis represents capital. Different points along the curve show combinations of labor and capital. As the usage of labor increases, the usage of capital decreases to produce a certain level of output. An isoquant is a curve that shows the various combinations of two inputs that will produce a given level of output. The slope of an isoquant indicates the rate at which factors, capital and labor, can be substituted for each other while a constant level of production is maintained. The slope is called marginal rate of technical substitution. Figure 3.11 depicts marginal rate of technical substitution. The x-axis represents labor and the y-axis represents capital. The changes in the ratio of capital to labor used to produce a certain level of output are shown. The absolute value of the slope of the isoquant is the marginal rate of technical substitution between two factors. Thus, the marginal rate of technical substitution is the rate at which labor substitutes for capital without affecting output. When more capital and less labor are used, the marginal productivity of labor is relatively large and the marginal productivity of capital relatively small. Hence, 1 unit of labor will substitute for a relatively large amount of capital. Anywhere along the isoquant, the marginal rate of technical substitution for labor for capital equals the marginal product of labor divided by the marginal product of capital, which also equals the absolute value of the slope of the isoquant. Marginal rate of technical substitution is equals to marginal product of labor upon marginal product of capital. Properties of isoquant. Number 1. There is a different isoquant for every output level, and farther from the origin indicates higher rates of output. Second, isoquants have negative slopes indicating the quantity of labor employed is inversely related to the quantity of capital employed. Point number 3. Isoquants do not intersect, since each isoquant refers to a specific rate of output. An intersection would indicate that the same combination of resources could, with equal efficiency, produce two different amounts of output. Fourth, isoquants are usually convex to the origin, so an isoquant gets flattened as we move down along the curve. Exceptions to isoquant curve. There are exceptions to the isoquant curve, and it can have three general types of shapes. 1. Perfect complements. The isoquants are right angles, indicating that inputs A and B must be used in fixed proportions and therefore are not substitutable. For example, the left shoe and the right shoe. Second, perfect substitutes. Input A can be substituted for another input, say B, at a fixed rate as indicated by the straight line isoquants, which have a constant slope and marginal rate of substitution. For example, jaggery and brown sugar are often nearly perfect substitutes. The x-axis represents amaco gas and the y-axis represents texo gas. As both are perfect substitute for each other, so whether the consumer uses amaco or texo does not make a difference. Hence, the curves are straight lines. Figure 3.13 depicts perfect complements. The x-axis represents typist and y-axis represents typewriters. Both inputs should be used in fixed proportions as they cannot be substituted. Hence, the curve will be right angles. Imperfect substitutes. It is the rate at which input B can be given up in return for one more unit of input while maintaining the same level of output as the number of inputs increases. For example, in farming, harvesters and labor for harvesting grain provide an example of a diminishing marginal rate of substitution, considering capital and labor are imperfect substitutes. 3.5.3 Choice of input combination. The input combination used can be shown with the help of iso-cost lines. Iso-cost lines show different combinations of inputs which give the same cost. It shows the various combinations of two inputs that can be bought for a given dollar cost. The slope of the iso-cost line is given by negative wage upon rate of interest. The equation for an iso-cost line is labor into price of labor plus capital into price of capital. Marginal rate of technical substitution of labor and capital is equals to marginal product of labor upon marginal product of capital, which is equals to wage upon rate of interest. A producer aims at either maximizing output for a given cost or minimizing cost subject to a given output. Case 1 depicts the maximizing output for a given cost. In figure 3.14, the x-axis represents labor and the y-axis represents capital. An iso-cost line, which is the budget line for the producer, is drawn along with different isoquants representing different levels of output. The higher the isoquant, the higher the level of output, but the maximum output will be at a point where the isoquant intersects with the iso-cost line, that is Q. The producer will achieve maximum output at this point. Case 2. Figure 3.15 depicts minimizing cost subject to given output. In figure 3.15, the x-axis represents labor and the y-axis represents capital. An isoquant which shows a different combination of factors by the producer is drawn along with different iso-cost lines representing a different amount of cost. The point at which the producer will minimize cost will be where isoquant is tangent to iso-cost line, that is Q. The producer will choose the best input combination as per the costs and availability of factors, choosing the economically efficient point of production. The least cost combination of inputs for a given output occurs where the iso-cost curve is tangent to the isoquant curve for that output and where the output is highest. Figure 3.16 depicts least cost combination of production. In figure 3.16, x-axis represents labor and y-axis represents capital. The least combination is at point A, where the isoquant curve is tangent to the iso-cost line. The point B and C are on higher iso-cost lines but are not tangent. Hence, the equilibrium cannot be reached. Relevance to business. Applicability of choice of combination for production will be explained through an example. Consider the choices available for manufacturing cars is given in the table above. 5 different techniques are available. Technology A is the most labor intensive, requiring 120 hours of labor and 50 units of capital to produce 100 cars. E is the most capital intensive, requiring maximum units of capital. For choosing the best combination, firms must look into input prices of labor and capital. If the price of labor and capital is $1, then firms will look at the minimum cost, which will be using technology C. Now suppose wages increase to $5, then technology E will be cost minimizing for the firm. The flexibility of a firm's ability to change techniques of production plays an important role in determining its cost. Case study number 2. Since the 2000s, manufacturing firms in India have been relocated to places with lower land rental rates and labor costs, mostly in the outskirts of the city and small towns. At the same time, firms in service sectors like finance, insurance, information technology, etc., have been locating near the city centers and contributing towards urbanization like Millennium City, Gurgaon. One of the major reasons seems to be that manufacturing firms find it difficult to substitute capital for land, and service sector firms do not require a lot of space. 3.6 Summary. 1. A production function shows the relationship between the number of inputs used and the amount of output produced in a given period. Second, in the short run, one of the factors of production is fixed. Third, production in the short run is subject to diminishing returns as the quantity of variable input or factor increases, the marginal product diminishes. Fourth, in the long run, all the factors are variable. Fifth, an isoquant curve shows the combination of different factors at a particular level of output. Sixth, isocost is the cost incurred or budget of the producer. Seventh, for the efficient outcome, isoquant should be tangent to the isocost line. Thank you for listening.